how to record data. First, we're going to take a look at two important categories of numbers in chemistry: exact and inexact numbers. Exact numbers are numbers that have infinite precision. For example, pi. Pi is an irrational number, but we know exactly what the value of each digit in each place value is. Another example of an exact number is the conversion factor 12 inches is equal to 1 foot. There are exactly 12 inches in 1 foot. And counted numbers are considered to be exact as well. For example, 9 students in a classroom. On the other hand, measurements are considered to be inexact. There is always some uncertainty in a measurement that is due to the limitations of the measuring device. So let's take a look at this measurement here, 1.25 centimeters. First, we notice that the measurement is written out to the 100th place. We do not know what the value in the 1,000th or the 10,000th or the 100,000th place is. So all the place values smaller than the 100th place value are unknown. So that's uncertain. Then, in a correctly recorded measurement, the last digit is considered to be estimated or uncertain. And it is usually plus or minus 1 of that last place value. So for example, this measurement, 1.25 centimeters, we know that the 1s and the 10th place value are known with certainty, and it is the 100th place that is estimated. So the actual length of this measurement is somewhere between 1.24 and 1.25 centimeters. Between 1.24 and 1.26 centimeters. So when we are correctly recording a measurement, a correctly recorded measurement reflects the precision of a measuring device. The last digit is always uncertain or estimated, and that estimated digit is considered to be plus or minus 1, whatever that last place value is. If the precision is greater than plus or minus 1, then it has to be expressly written. I am going to go through some examples of how to correctly record measurements. My examples do not include units, but I want to say very clearly that units are an important part of a measurement. The units indicate the physical property that is being measured. Milliliters represents volume, kilograms, mass, joules, energy. In a lab report, you must include the units. You will lose points on tests and lab reports if you do not include the units. So let's look at an example. Here I have a fictitious measuring device, 2 actually. I'm going to look at the top measuring device, and I'm going to look at correctly measuring the value of A. The first thing I want to do is I want to see what each graduation stands for. And between 2 and 3, there are 9 graduations. So A is between 2.3 and 2.4. So I know for certain that where A is greater than 2.3. I'm going to estimate the distance between 2.3 and 2.4. It looks to me like A is a little bit greater than exactly halfway between 2.3 and 2.4. So to correctly record this measurement, I'm going to write 2.36. Anyone looking at this measurement would know that the hundredths place was estimated and that the actual length is somewhere between 2.35 and 2.37. Now let's look at B. This arrow looks like it is exactly on 3.1. If I were to write 3.1, that would indicate that my point 1 was estimated. And it's not estimated because that point 1 is a tick mark on this measuring device. So to accurately reflect the precision of this device, I need to have a 0 at the end. This 0 is my estimated digit, and anyone looking at this measurement can tell that the ones and the tenth place are known for certain in this measurement. In a given measuring device, the number of place values after the decimal point has to be the same for every measurement. So A is taken to the hundredth place, and B is taken to the hundredth place. So D, if I were to write the measurement for D or C, those measurements would also have to be written to the hundredths place. It is the hundredths place that is the estimated digit. The tenths we know for sure. Now, it's not always the hundredths place that is estimated. It depends on the instrument. So if I look at this lower measuring device, I see that between 0.02 and 0.03, there are 9 tick marks. So that means that E is between 0.024 and 0.025. One of the first things I do when I look at a measuring device is I count off these tick marks and I figure out what value those tick marks represent. In this case, they represent the thousandths place. So E is in between 0.024 and 0.025. It looks to be exactly in the middle. So I'm going to write the measurement for E to be 0.0245. My 5, or the 10,000th place, is my estimated digit. Anyone looking at this measurement would know that the hundredths and the thousandths place are known for certain, and it's the last digit that is estimated. Now let's look at G. Actually, no, let's look at F. F is right on that tick mark. And you might want to just write 0.030, but that would not be correct. We need to accurately reflect the precision of the device. Because E has 4 place values after the decimal point, F must also have 4 place values after the decimal point. So to correctly record the data for F, 0.0300. So when you are recording data, the last digit is the uncertain digit. And if a measurement is taken right on a tick mark, you have to be sure that your measurement has enough zeros after what you are reading so that it reflects the precision of the device.